In this session, we will see the k-means practical, and one of the uses of k-means is color segmentation. So the code which we will be using, it will simply assign pixels to the same segment if they have a similar color. And one of the application of this color segmentation is to analyze the satellite images to measure the particular area. Say for example, you are concentrating on the forest area, then it will be in the green color, and we will see it practically. We will see two more examples in this program where we will analyze two different images to understand the color segmentation using the k-means method. So let us start with the code. In the first cell, we are importing the required library. We are importing k-means from the sklearn.cluster. So we are using scikit for this practical, calling the imread function to set the image, and I have taken the satellite image first, and then we will see two other examples. In the second line, we are showing the actual image. We are dividing it by 255 to keep the image visible in the plot, and then finally we are reshaping the image to the 640 by 526, which is the size of the image, and 3 is for the RGB image. So let us run this cell to see the output. First you can see the array, and then you can see the image. So this is the Australia continent, where you can see the green area on the border, and somewhere in between. Now we will get the x. Since we are working on the unsupervised learning, we need only x for our k-means algorithm. So we are extracting x from the image, and then we are applying the k-means. Initially we are starting with the cluster is equal to 3, so I'm setting k is equal to 3, and I'm fitting the x. You don't need to fit anything related to y because you don't have the labeled data here. And then I'm getting the segmented image, and finally I am reshaping the image with the size of the actual image. And it may take some time based on the number of clusters you have. If you have more number of clusters, it will take more time. What it will do, basically it will cluster the pixels into the three most dominating colors in the image. So now if you plot the image, you can see that the image has been changed and it has been modified with the three dominating colors. So you can see the blue color in the outside, which is the color of the ocean, and then you have some green color, which is the forest area, and then the land area in the brown color. Now if you compare the pictures, the picture which was the original, there were some points in between the continent. This is the Australian continent picture. So there were some points where you could not see the forest clearly, but after applying the segmentation, you can see some area in between where you can identify the forest, and you can measure that as a part of the forest because the green color has become more prominent now. And the color segmentation is used for 3, so it has picked up 3 most dominating colors, and then it has clustered all the nearby points, all the points with the various shades of that color, and then it has clustered them. Let us take another picture, and now this picture is having multiple colors, so I'm just commenting the first picture. Again, we will be repeating the same method, and you can see the original picture, and you can see some colorful gems there. Again, we are reshaping to get the x, and then we are applying the k-means, and then we want to see the picture how it looks like. So now if you see, the picture has changed completely, and it has picked up only 3 colors. Now these 3 clusters refer to 3 colors which has been identified, which were the most dominating colors in the picture, and then they have been used to cluster the image. Now if you change it to, say for example, 6 clusters instead of 3, and if you rerun this, it will take longer time than the 3 clusters, because now you are dividing the image into the 6 dominating colors. The image will be clustered for 6 colors, and then if you see, you can see now 6 major dominating colors, so, and the image is divided into that. So this is how you can use the k-means for the multicolor images. And let us take one more example with another image, and this time we will be using a ladybug image. Let us run this step again. This is the actual image. So you can see a ladybug on a leaf of a plant. Again, let us extract X. Let us keep this to 4 and let us run the k-means. Now if you observe the picture, there are mostly green, red and black colors. So let us try with the 4 clusters and let us see how the image is getting changed. So now if you see the image is mostly changed, but you have now the ladybug which is clearly visible and it is dominating in the picture. So you can distinguish this as an object in the picture. You can consider this as the method of separating the objects in the different pictures. There are multiple uses of unsupervised learning. We have seen the basic use using the color segmentation in this example, and you can explore it in detail for different types of applications related to your domain.